Okay, moving right along. Now we have the area of a square. So the area of a square is given by the formula side times side. All four sides of a square are equal. So that means the horizontal dimension here in this case is 8 centimeters. But since all sides are equal, it means the horizontal and the vertical dimension of the square is 8 centimeters. So we take the horizontal dimension, which is side, and we take the vertical dimension of the square, which is times side, and then we substitute 8 centimeters times 8 centimeters gives us 64 centimeter squared. So that's the area of a square. Simple, straightforward. We go to the area of a rectangle. Not a rectangle, a triangle. I don't know why I make that mistake, but area of a triangle is given by the formula area is equal to half base. Now, a base of our triangle is always, if you have a height, a perpendicular, which is basically 2 centimeters, the height perpendicular is also with a 90-degree angle. Now this height perpendicular, at the feet or at the foot of the height, you will have what you know as the base. So this is the base, all right? This is the perpendicular height, all right? So a formula here, it will always be half base. So that's B stands for base. If base is at the foot of the height, so the foot of the height is 4 centimeters. So we're going to substitute half base here to 4 centimeters times indoni height, which is 2 centimeters. So then if we multiply that, we get area, which is 4 centimeter squared. Simple, straightforward, nothing much to it. It's a matter of knowing where the base is. It's at the foot of the perpendicular height. So that's how it goes. Then we have another example of a triangle. This triangle is an acute angle triangle. And basically what you can see is that the perpendicular height is inside the triangle, from the apex to the foot of the triangle. So therefore the foot of the triangle, the base, is actually BC, the entire length of the foot, which is basically BC, right? And those lines would suggest that half of lot 12 will give us 6, 6, if that makes sense. And let's say they had asked you to calculate the length of AB, you'd use Pythagoras to find the length of AB. That's just something else to note. So half base, base here to 12 centimeters, times the perpendicular height here, which is internal to the triangle, which is 5 centimeters. Substitute that, half base times that perpendicular height, you get a nice answer of 30 centimeters squared. If you have an obtuse angle triangle, obtuse angle triangle has a perpendicular height that is external to the triangle, because from the apex to the same horizontal plane where BC is, this is basically the perpendicular height, right? But the base of the triangle, because this is BC, the actual length of the triangle, it's not from here to there. BC is the actual base length of the triangle. This is basically base angle 3 centimeters, but the perpendicular height is 4 centimeters. So you simply just say half base times perpendicular height, you substitute, you get a beautiful answer of 6 centimeters squared. In the substitution, you can use your calculator and just get the answer. So you write the formula, you substitute, answer. Formula, substitution, answer. Formula, substitution, answer. Formula, substitution, answer. That's how we basically go about this thing. Okay, and don't forget, for area here too, it's always in square units, the answer here too. So you must make sure that you have that centimeters squared if it's centimeters, millimeters squared if it's millimeters, kilometers squared if it's kilometers, units squared if it's units, and so it goes. Okay, I'm gonna move on to a circle next video.